We can exploit the methods that are already in place, at least some of the methods that are in place for folded proteins, and extend them to unfolded or intrinsically disordered proteins. So it's a matter of finding the right way of extending them. But I think you know, there have been great advances in this direction, so one can be optimistic. Well, you have to be a bit creative in finding the coordinates. Some of those that we normally use are certainly useful, also for IDPs, and some others will have to be invented. It will depend on, you know, what the mechanism of function of IDPs are, and so the coordinates will describe those. We'll understand that. So if you think about the traditional drug, so a small molecule, it would seem to be completely hopeless to bind a disordered protein, because in order to bind, you have to to create a balance between entropy and energy. And the small molecules will never provide enough energy to beat the entropy that is lost. So from that point of view, it seems completely hopeless. But here, it may not be, because we may change slightly our thinking about how the binding takes place. So the binding of a small molecule to an IDP may be rather different from the binding of a small molecule to a folded protein. So now we don't know the binding of a small molecule to an IDP, but we know by experimental means that they can bind. So now the issue is to understand what's the mechanism of binding. It has to be different because the standard way of binding is impossible. But there must be another explanation, because we see them binding. So. Well, that would be a powerful strategy, although from the point of view of solving the binding problem, but the drug is much more than binding. So if we can find molecules that mimic IDPs and can be developed into drugs, then that would be ideal. Otherwise, the small molecule strategy has the great advantage that we know very well. Well, it's still difficult, but we have a great experience in developing small molecules as drugs. So it's both routes are worthwhile exploring.